So thanks everyone for coming here today. I know there's a lot of really exciting talks that you could have been to, so I really appreciate you coming to this one. So why are we here? Long build times suck, right? No one really likes them. Imagine the amount of times that you were super excited about a code change or something you just wanted to see happen, and then you had to wait 2, 3, 5 minutes, and you're wondering what's really going on back there. Right? No one likes it. So just to put some things into perspective, we're going to see some time measurements and how certain optimizations affect your build time. So just to put things into context, let's talk about why build times matter, okay? So let's think of a medium-sized team of about 50 developers. That's medium-sized to me. Maybe that's different, give or take. And each developer is doing around 20 builds a day. And let's say we somehow manage to improve the build speed by 30 seconds, which is quite significant, right? But let's say all 50 developers put their heads together and we're able to bring down the speed by 30 seconds. That's more than 8 hours a day that gets saved. That's an extra engineer. And I don't know about you, but usually when I hit build, I don't sit there watching paint dry and then start working when the build finishes, right? I go take a coffee break. So honestly, it's 10 minutes of build for me, when you look at it that way, 10 or 15. So I mean, developers like optimized builds because it gets you to do your work faster. It's less disruptions in your day. And then the company, makes money by saving engineering hours. They can hire an extra engineer to make sure they hit all their goals for the quarter, right? So everyone wins when we optimize our build speed. So let's take a look at a real-world example. So this is a Santa Tracker project. It's available from the Google GitHub repository, so you can pull it, download it yourself, and try everything out that we're going to do. But just an overview. There's about 9 projects or modules. I mean, what Gradle considers a project, Android Studio considers a module. So there's about 9 modules. So Gradle has to configure those 9 modules and prepare a task dependency graph for over like 500 tasks. And then it's got to resolve more than 100 dependencies. And after it's not even considering all the code it has to compile out your resources like XML, and there's about like 7,000 image files. So it's a decent sized project, right? So just to get a clean measurement here, so we're going to do a clean build using Android Studio 2.3 with the 2.3 plugin. It's using Gradle 3.3. And so what I did was did a couple of clean builds using Android Studio, and the reason I do that is because there is kind of like this warm-up effect for the JVM. It needs to know, like, before it gives you the amount of resources that you're really going to need. So after doing a couple of those, this was the first build. So it's pretty long, right? 2 minutes. Can you imagine waiting there 2 minutes? And also like sync time, because your configuration phase has to configure all those 9 modules. Is about 1.5 minutes, and then just a clean, just to remove all your intermediate build files, it takes more than a minute to do. So that's our starting point. So there's some basic optimizations you can do. We can do before we even upgrade the plugin version, which you can do probably sitting at your seat right now on your laptop. So first one is min SDK version. Put that to, sorry, I made a mistake there. That should be 21 or higher. So set your min SDK version to 21 or higher, because that avoids legacy multi-dex. And what that was is basically a certain point when the dex format has a limit of indexing 64,000 methods, right? But then apps kind of exploded in complexity. You started adding Google Play services that added a bunch of methods, and soon 64,000 wasn't enough. So we introduced multi-dex library, which gets compiled and packaged with your app when you're on lower than 21, which on the device kind of handles method calls across multiple dex files, right? So it kind of slows down the whole compile process when you're running all your, when you're running multi-dex support through that library. So 21 and higher has native support for multi-dex. So setting your MinSDK version to 21 or higher takes advantage of that. What you can do is actually create a developer, because MinSDK version is on the flavor or default config level. So what you can actually do is create a flavor just for your development build. And we'll see a couple other properties that you can kind of chuck in there. And then whenever you're working and iterating, just deploy your development flavor. So dynamic version numbers, get rid of them. So what do I mean by dynamic version numbers? If you can see right here, here's the version number for the support library. Some people put a little plus sign, and it tells Gradle, hey, look, I want 24.2. Whatever you got, whatever the highest one is. And that sounds great, right? But every time you build, Gradle has to ping the repo, find out what the version, available dependencies are, grab them. And then if you have slow connection, if you're getting slow response from the repo, then your build's going to be slower. And in addition to all that, let's say you're iterating, and then a library author puts a new version of their library up, change some public APIs, and then things start to break, and you're just wondering what happened, right? Because it was changed underneath you, and you didn't even know what is going on. So don't do that. Do that. Just static version numbers, and you're more in control of your project, right? Filter resources. So when you're iterating just on logic, you don't need every locale in your app. You don't need images at all the densities that your app supports, right? So that's where res config comes in. Instead of Gradle having to compile all those resources every time you build, put res config, again, because it's on the default config object, put it on your flavor that you set up just for development, and just keep the resource that you want. So English locale, if that's what you speak, and then high density, or whatever your device needs, right? And speaking of device-specific configurations, disable multi-APKs, because every time you build, Gradle still has to figure out and create the tasks for all the different outputs that your project supports, right? So again, just while you're developing, just kill multi-APKs. So the problem with the splits block for configuring multi-APKs is it's not defined at the flavor or build type level, right? It's a separate block. So what you can do here is actually pass in a property. Tell Gradle to look out for a certain property that you can pass in through the command line, and then set these properties when it comes to that, when it sees dev debug. I'll show you how that looks. So if you're doing that from a command line, there's your command line, and then you're passing the dev debug property. And on Android Studio, you can go to build execution deployment in your preferences, compiler, and just add the command line options there. Just remember you have to remove that when you're doing any other, like if you're building a release version. Okay, configuration on demand. Let's say you have, so this is an incubating feature from Gradle, and it's designed so that it only executes the build.gradle file for the modules that are actually participating in your build, right? So one caveat is that the root project is always configured, so keep it light. Don't put any build logic in there. You shouldn't in the first place, but just something to keep aware. Another caveat is that modules need to be decoupled. And what does that mean? So that means like if I have an app module and it's reading properties from a library module, they become coupled. So every time Gradle has to configure both because the app is dependent on output or objects in the library module, right? So having said that, now back to point number 2, though. Since we are always configure the root project, if you have properties that you want global, like for certain version dependency version numbers that you want consistent throughout your modules, put them in your root project because that's configured anyway. So in your Gradle.properties file, all you have to do is add this to enable that feature. Parallel execution, another great easy one to do, and it just takes advantage of multiple cores, right? So executes your build over multiple JVM threads. And it's great if you modularize your app, right? So if you have more and more logic that's kind of put out into libraries, Gradle is able to start the build process for each of those modules on separate threads. And this one, I think the default, you don't need to add this, the worker max. It's just default, the number of CPU cores you have. Disable PNG crunching. Now, PNG crunching is great if you have a lot of PNG files. It's great for your release build because your users want super small APK sizes, but don't enable PNG crunching for your development build. Because every time you build your app, Gradle has to process or compress your PNG files. And we saw the Sander Tracker app had almost 7,000 PNG files, right? So in 2.3, you actually have to set the cruncher enable to false. And again, this is not on the flavor or build type level, so you can add use that trick that we saw earlier for the for disabling multi-APKs and add it just based on the parameter, command line parameter. So just a brief thing about 3.0, I know we're not into that yet. We actually realized that it's probably bad for debug builds, so we disable it by default for debug builds. So just remember for your release build to enable it. And we did move that property to the build type level, so you can do that there. And the name has changed, so just note that. So having said all that, what you really should be doing is converting your PNG to WebP files. So WebP is a format that is already optimized, and you'll see about up to 25% reduced file size, while avoiding build time compression. So you don't have that slowdown when you're at build time. And it still has all the things that you love, which is transparency for API 18 and higher. One thing to note, though, is on the device you may notice higher CPU usage because the device has to decompress those files. Another good thing, useful thing is on 2.3, Android Studio 2.3 and higher, we have a tool that helps you batch convert your PNGs to WebP. You can set the compression ratio and see how that actually affects the quality of your image and everything. Oops. OK, so just a recap. Basic optimizations, we increased the min-SDK version. We removed dynamic version numbers. We're filtering all the resources that we don't need while debugging our app. Disabled multi-APKs, enabled configuration on demand. We enabled parallel execution, and we disabled PNG crunching. So let's go back to our app. So same version of the plugin, same Gradle version. Before we were at a little less than 2 minutes. Now, just with those optimizations, we're down to 56 seconds. Right? Yeah. And you could have done that right now while I was talking. You could have cut your build time in half. And same thing with sync and clean, because we've also optimized the configuration phase. So those basic tasks are also a lot faster. All right, so getting into using the 3.0 plugin, right, the new Hotness. Well, actually, it's 3.1 in Canary, but still. So if you, this is going to be super simple, so I'm just going to fire right through this. But if you didn't already know, if you're on an existing project and you're on 3.0, Android Studio 3.0, but you didn't update the plugin, if you do update to 3.0, it gives you a bunch of dialogues to update Gradle and the plugin and all that. Just click OK to those. But here's just the dependencies. And then in your Gradle wrapper.properties, just update that. You also need, in order to actually get the plugin, you also need to add the Google Maven repository. So in Gradle 4.1 and higher, Gradle added the Google keyword for our Maven. And what that allows you to do is actually just download SDK components like any other Maven artifact. So you don't need to go through the SDK manager and download a huge blob for just certain dependencies or certain artifacts that you want. So this is all you really need for the plugin to put it in your build script repository. But if you want it for your modules, for those other SDK components, put it in your sub-projects closure. One thing I will note that there is some flakiness if you don't put the Google keyword first. And I promise this is not a marketing attempt to put Google ahead of all the others. But there is some flakiness that we've noticed. So if you're experiencing that, just try putting Google first. OK, and then update the plugin. This is super easy, right? Cool. So here's the theme. Like the build team and the Android Studio side worked very closely with Gradle for 3.0 and even today, right? The continuing to work. And the common theme is just avoiding unnecessary work. It's like, how can we get Gradle to identify tasks or basically tasks that it doesn't need to perform to satisfy the build that you want, right? To create the specific flavor or APK that you're trying to build and deploy to your device. So the first thing we'll talk about is compilation avoidance. So before we get into that, let's just take a high-level look at our Santa Tracker app. This is very basic. We're actually missing quite a few modules here, but so I mean, there's a Santa Tracker app. There's a bunch of local library modules, and then a common library module for the dependencies that we want to share across all the other libraries. So what is the dependency configuration? Well, if you look on the app right now, almost all of them are using the compile configuration, right? And majority of people are going to use the compile configuration. What it does is it adds the dependency to your compile class path and also packages it into your APK so you can use it at runtime. And seems pretty straightforward, you know, how could that be so bad? And then you have APK when you have already like a compiled like jar binary, you just want it at runtime, and provide is the opposite, where it's just at compile time only. So, okay, so back to our graph here. So these are all compile dependency configurations, right? But it gets a little more complicated than that, right? So each of those libraries will probably have dependencies of their own, and you can imagine this keeps on going. Like if you've modularized your app, you'll have more dependencies. Even lib1, lib2 will have their own dependencies. So lib1, lib2 are local libraries, and let's say you've made an API change. So a change to a public method that Dasher Dancer and Snowdown access. So of course you're going to have Gradle has to recompile lib1 and lib2, right? That makes sense. And because Dasher and Dancer and Snowdown access those public APIs, they're going to be recompiled as well. But here's the thing about compile configuration. That one keyword is not enough for Gradle to know whether the dependency, like lib1, is something that you expect only Snowdown to use or Dasher Dancer to use, or you also want to transitively expose that dependency upstream to your Santa Tracker app, right? It's not enough information. So the compile assumes transitivity. It just assumes that upstream dependencies are also going to want access to those APIs. So what ends up happening is not only do you have to recompile lib1, lib2, those modules there, but it ends up recompiling your app project. And you can imagine for more complex projects, you can end up recompiling modules that, and again, this is assuming that the Santa Tracker app actually does not use any of the APIs here. It just has access to those APIs, but Dasher Dancer is the only consumer of the APIs in lib1. But you still have to recompile it. So that's the problem with the compile configuration. So what Gradle did was they introduced two new configurations, essentially. One called implementation, and the other is API. Implementation tells Gradle that this dependency, I only expect the direct consumers to have access to that API, and no upstream consumers, right? And then there's still another configuration, API, for all intents and purposes, works exactly like compile. So use with extreme caution, right? In fact, most of the times, let's say you end up leaking the APIs for lib1 upstream. Instead of adding that as an API dependency, just add that to whatever modules that are using those APIs as an implementation dependency. So if we look here, so we changed all of it to implementation configurations. Lib1 and lib2 gets recompiled. Dasher, Dancer, and Snowdown get recompiled, but that's it. The buck stops there, and we don't have to recompile the main app. So here's the thing, they haven't fully deprecated compile. You can still use it today, even on 3.0 or 3.1, but you really, really should not do that. It's super easy. just do a search and replace. Just find all your compiled dependencies and just turn them into implementation, right? It's almost as easy as that. You probably will get into a couple of build errors and then you discover that you're actually using some APIs that aren't direct dependencies. And again, instead of turning those dependencies into API dependencies, just add them to whatever modules that are using those dependencies as an implementation dependency. And these configurations also work with variant-specific configuration. So if you had like release compile, debug compile, you can do release implementation, debug implementation. Do people kind of understand those configurations? Yeah, okay, great. Okay, that was so much hard work, so we decided to give you a freebie. Here's an optimization you don't have to do anything for other than migrate to 3.0. You don't have to really do anything for it to get. So improved parallelism. So let's look at how things used to be. So we have an app module here, and it's going to consume this lib1, right? So before, lib1 had to go through all its tasks. It has to do manifest merger, resource merger, compile its resources with apt, compile its the logic with Java-C, packages that all into AAR, send that to the app, but then the app needs to unpackage it to be able to actually see the components within the AAR. It has to unpackage the AAR, and then the app has to do its thing, and then finally package the APK, right? Super inefficient, no parallelism there at all. So let's take a look at how it happens now. So the build team, the Android Studio team, worked very closely with Gradle to create APIs that allow each of those library tasks to export their artifacts as discrete artifacts to tasks in the app build chain. So now what happens is like you don't even need the AR packager. Like the manifest merger, the app gets to manifest merger. It's like, oh wait, I'm waiting for output from the manifest merger from lib1 because it's a dependency. So, but as soon as that's done, it just sends off the output to that task of app. And same thing for all those other tasks, right? So both can be built in parallel. So there's a freebie for you. So variant-aware dependency resolution is the next one. This one, depending on how complex your build is, like we did quick survey, most of you guys are using product flavors and different variants. So this could be a little painful. So what is variant-aware dependency management? Basically, the plugin is now able to, for the variants in your app, it automatically matches to the variants in your dependencies. It also alleviates the configuration phase because now Gradle doesn't have to execute all the build.gradle files to figure out what variants you have here, what variants you have there, and how you want to match it up. What happens is the app provides a set of its variants, the dependencies provide a set of its variants right off the bat, and then Gradle is just like, okay, these two match. I'm just gonna configure and work with those variants there. So here we see like we have a build type. Let's say this is app. That's your library. We have build type debug, build type release. Super simple. It can't get more simple than that. And then Gradle just matches those two, right? So before, this is what you had to do. In dependencies, you have debug implementation. Well, actually, this would be debug compile. But anyway, so you'd have to do that. So for your debug build type, you want to add the debug version of the library, and same thing with release. But now, this is all you have to do. In your dependencies, just implementation project, that library, and Gradle takes care of the rest. Almost, but we'll get into that. Same thing with your library module, if you're just consuming your library module locally, the plugin doesn't really care about, no longer really considers these properties because it automatically publishes all variants of your library to the app. So what about product flavors? So we talked about build types. How does this work with product flavors? And does it get more complex? Yes, it does get a little bit more complex. First of all product flavors now need to be belong to a named flavor dimension. So even if all you had was a free and paid flavor, you have to add it to a dimension, even if it's just there's only one dimension. Let me really quickly describe what flavor dimensions are. think of flavor dimensions as groups of flavors, of related flavors, right? So you could have one flavor dimension that's like versions. That's probably a bad name, but it's like for your free version, your paid version, your demo version, right? And then you could have a dimension for like different API levels that you're targeting. So you can have min API 23, stuff like that. And then the actual variance you do have is like cross product of those dimensions. So if you don't have dimensions in your flavor, you'll get a pretty concise error output to just add your flavors to a dimension. So it's pretty simple. So this is the free and paid flavors we were talking about. So create a dimension, name it whatever you think is appropriately describes those flavors, and then assign each of the flavors to a dimension. So since we only configured one, we just add that. So here we can see, so we have the same, we have debug and debug version of your apps. First time, like if you're building the free version, pairs it up to debug free on the dependency side, and same thing for the paid, right? So super simple. Now, what about this scenario? Your app has debug build type, and then it configures a version a flavor dimension, but then your library doesn't use flavor dimensions. It doesn't use flavors at all. Who thinks that this is going to work? Nobody thinks this is going to work. Actually, it works pretty fine because Gradle's smart enough to know that the plugin's smart enough to know that okay, we don't care that you don't have a product flavor. We know that debug is good enough for this case, so that'll be fine. But what about missing flavors? What if your app is missing flavors that the dependency configures? So let's take a look here. So we have debug and we have version free, and both the app and the library dependencies configure the version flavor dimension, but there's no free. Instead, they're using demo, right? So now at this point, the plugin doesn't really know which one to pick. Do I pick demo or paid? But we have a solution for that. So in that case, well, you do get this error, and this one's quite cryptic, and it's because once the plugin publishes to Gradle the variants on the app side and the variants on the library side, we actually don't know what causes the error in the Gradle side. So we just kind of get this cryptic error message from Gradle. So just a heads up. But so if we have that case, when your app uses a flavor that library doesn't, you use a matching fallbacks DSL property. So here what happens is for free, we saw that the dependency didn't have a free version. This Gradle will still automatically look for a version free in your dependency. If it doesn't, you're able to provide fallbacks for that. So if free isn't available, it tries demo, and then it tries trial. Let's say another dependency has a trial version, right? Okay, what about missing build types? Actually very similar, right? So we have staging here, debug, release. Gradle plugin doesn't really know what to do. So again, use matching fallbacks, and this time you specify it in the build type that you want the fallbacks for, right? So for staging, we tried debug. Maybe there's a QA, and if it has neither of those, let's just take the release build type. And here, if release is found, like you don't have a problem, like all your modules use release, then you don't really need to add this, right? So what about missing dimensions? This is the last case for this, but this one's slightly more complicated, right? So you have debug version free, but then your library doesn't really discriminate different payment methods, like whether it's free or whatever, it doesn't care. But it does support, have flavors for different min API levels, right? So again, Gradle doesn't know what to do. So what you can do is use the missing dimension strategy DSL property. This one you can configure it in the default config, and that's because if there's a whole dimension that your app isn't configuring, and you want this strategy to apply to all your flavors, you can just put in the default config, right? So here's the default, like for min API, pick 18 first. If 18 is not available, pick min API 23. However, you can override that property for the same one Actually, let me just back up just to be clear. So the first argument here is the dimension name. So min API, when Gradle encounters a min API dimension, pick that flavor. If that's not found, then pick that flavor, right? So you can override that in the product flavor block. So let's say for your free, you really don't want to support min API 18 and higher. You just want to support min API 23. You can just override that just for your free product flavor. More freebies, because that was a lot of work. Okay, so per class dexing. So dexing is now done on the class level, and this is great because improves your incremental build speed. So if you do a code change to one class, the plugin, Gradle only needs to recompile and create a new dex file for that class. Before, it was when everything was like was not at the class level, it has to recompile the dex files for whatever classes are in that dex file, right? Right. So okay, and then cacheable tasks. Okay, I lied. This one you have to do a little bit of work. You have to add this into your properties file. But cacheable tasks. So Gradle introduced a bunch of APIs so that you can actually mark for a given task. Here are the inputs to that task. Okay, and then you can actually mark here are the outputs for that task. So the first time you run it, the task is going to get a bunch of inputs, and then Gradle's going to get it's going to create a bunch of outputs, and then Gradle will cache those outputs. The second time you do a build, and let's say you touched nothing at all, it's a no op, you're just rebuilding again. Gradle is going to look at those inputs and be like, you know, nothing has changed here, so chances are the outputs have not changed, so we're just going to pull whatever's in that cache. And so it avoids a lot of unnecessary work that way. And more Gradle plugin tasks, Android Gradle plugin tasks are taking advantage of this API, so it pays to kind of be on the latest version for sure. So let's go back to our standard tracker app. So again, just to recap, 9 modules, more 500 plus tasks, almost 100 dependencies, a ton of resources. So now I'm using the latest plugin, so 3.1 beta 1 is the latest on Canary. Okay, I'm running out of time, but I think this is the last slide. So this is where you can start clapping. We're down to 32.4 seconds, which is, and that's all I did. I mean, just applying the 3.0 plugin, right? So if you need any further help, you can always talk to me. Go to developers.android.com. There's an article for optimize your build speed. There's also a huge article for migrating to plugin 3.0. I really just scratched the surface. You can see I'm already out of time, and I probably touched half the things that are on those documents. So check those out, and thank you very much.
And thank you for that.